So substitution is a great method, but sometimes it's not set up conveniently for substitution. And so we have another method called elimination, or sometimes it will be called elimination by addition. And it can really work, especially if it looks like the problem is going to have a lot of fractions in it. Sometimes it's easier to use this method. Okay, so this method's based on, let's say you have A, so if A equals B, well, then we know that you can go A plus C equals B plus C. That's a concept we've been using, and it's based on if A, B, and C are real numbers, that you can just add a real number to both sides. But what if C equals D? Well, then could you say A plus C equals B plus D? And you can, because what you're doing is you're substituting that C right there for what an equal value, which is D, okay? So that actually works, and that's true. Now, if you look at what we have here, then look over here, and what we're doing is we're saying, we're like adding the equations. The stuff on the left-hand side, A plus C, is equaling the stuff on the right-hand side, B plus D, okay? So it's based on that concept that you can add equations. So when you do these problems, you might have something like, oh, x plus y equals 7, and x minus y equals 5. Okay? And so the idea is, when you add these equations, you would have, you want them all lined up. You want your x's like in a column, you want your y's in a column, and you want the constants on the other side. So there is some formatting with this you want to make sure you do. But x plus x, well, that's 2x. That's not a problem. But what do you get when you have y plus a negative y? Those cancel out, right? So those are out, they eliminate, and then you get on the other side, 7 plus 5 is 12. And that's the idea, and then you finish the problem, okay? So that's the idea behind it, is that you can add them, but you have to make sure something eliminates, okay? And that's where the work comes in sometimes. Okay, so we have one example here. Do I have two? Yeah, okay. So our first example here, sorry about that. If I were just to add those equations, I would get, well, I'm going to erase this, but let's see what happens. 3x plus 2x, 5x, right? Y and negative 3y, that'd be negative 2y equals 12. Okay, that doesn't get us anywhere. It's not that it's wrong, it just isn't helpful because I didn't eliminate anything. So, you know, it's an idea, but it's not going to help us solve the system of equations. It just gives us a third equation in two variables. So we have to make sure that something eliminates. All right, what we would really like is a 3 right there. If that were a 3, then we'd have 3y in the top equation and negative 3y in the bottom equation, and they would eliminate when we add them. Well, there's great news for us. We can multiply an equation by any real number, as long as it's not 0, on both sides. So I'm going to take that equation, and I'm going to multiply the whole equation by 3, and I'm going to get a new equation. Now, when I do this, I have to distribute to every term. Okay, so I'm going to get 9x plus 3y equals 15. So you're allowed to multiply by any real number, as long as it's not 0, and to both sides of an equation. You get to do that. The bottom equation, we're not going to do anything with that. We're just going to keep it. Or I'm going to copy it. So 2x minus 3y equals 7. Okay. Now when we add the equations, something wonderful is going to happen. And so 9x and 2x make 11x. This 3y and the negative 3y, those eliminate. Well, now it looks like a big empty set sign, but anyway, I don't know how you want to cross them out, but those are out because 3y and negative 3y eliminate. So you have to make sure one's positive and one's negative so that they'll eliminate. Okay, 15 and 7 is 22. Okay, so now we have an equation that just has one variable, 11x equals 22. All we have to do is divide both sides by 11, which is very convenient. And we get x equals 2. Okay, great. We know what x is. Well, these are systems of equations, and so we want an ordered pair. We need to figure out what y is. How are you going to find y? Well, you pick one of your equations. It doesn't really matter which one. Sometimes I pick the one with the smallest number. Sometimes I pick one that's just easy to find and write down. I'm going to take that bottom equation, 2x minus 3y equals 7. And some of you might be saying, well, why didn't you take the top equation? I could have. I just had to pick one. So this is the one I picked. You can pick the other one if you want. Okay, so I'm going to plug that 2 in. I'm going to substitute. So 2 times for x, so 2 times 2 minus 3y equals 7. And so what we're doing is we're taking this value 2, and we're putting it in right there. So that substitution idea doesn't really leave it. We use it a lot. Okay, 2 times 2 is 4. And then we subtract 4 from both sides. We get negative 3y equals 3. So I'm going to divide both sides by negative 3. And I get y equals negative 1. And so my answer is an ordered pair, x comma y, 2 comma negative 1. Now, some textbooks will just write x equals 2, y equals negative 1. But normally they write it as an ordered pair. So I'm just saying if you came from another textbook or something where they wanted you to do that, that's fine. Okay, now you can check those. I'm not going to on this problem. I'll check the next one. What's that? Okay, so here's another example. It says solve the system by elimination. So what we want is we want either the x's to eliminate or the y's to eliminate. It doesn't really matter which one you pick. I'm going to pick the y's. And the reason I'm going to pick the y's, I'll tell you, is because see how one of them is negative and the other one's positive? That's going to help me not have to deal with a bunch of negative signs. So that's how I'm choosing the y. I can choose the x, but it would be a different amount of work. And I don't think I'll do this problem twice. So I'm just going to do it once. Okay, the top equation, I'm going to, let me explain what happens. Okay, so I can't eliminate the y's just by adding them together because negative 4 and 3 don't make 0. So I have to think of a number that both 4 and 3 will go into, the smallest number preferably. And that would be 12, right? Okay, so if I had a negative 12 and a 12y and a positive 12y, that would work out just great for me. So what I'm going to do is I'm going to multiply the top equation by 3. I'll write it over here. And then the bottom equation, I'm going to multiply that by 4. So it's just like finding an LCD like we've done in the past. Okay, so let's continue. So we're going to get a new top equation, and it's going to come from distributing that 3 all the way across. So I get 9x minus 12y equals negative 27. Now, sometimes students forget to go all the way to the negative 9 with that 3. You got to make sure you multiply all the way across the whole equation, okay? All right. The bottom equation then is going to change also, and we're going to do the same thing. We're going to bring in that 4 to all 3 parts. So we get 20x plus 12y equals, okay, what's 4 times 14 real quick? 56? I think it's 56. Let me check my math. Okay. Yeah, now the great thing is you've got that negative 12y and that positive 12y. Now you'll notice that the numbers have gotten a little larger. That often happens, and the reason is we're trying to avoid fractions is what we're trying to do. So it doesn't mean that the answer won't be a fraction. The answer might still be a fraction, but we won't have it pop up till the end is what happens. So 9x and 20x is 29x. These are eliminating, negative 12y and positive 12y out. And now what's negative 27 and 56? I'm thinking it's 29. Check that on your calculator. Okay. Yay, this is great. Okay, so divide by 29. Divide by 29. And I'm getting x to equal 1. Now, you have to pick an equation to plug that x in. And you have 4 equations. You can plug it into any one of them. I'm going to choose this bottom original one. So let me recopy it over here. 5x plus 3y equals 14. And it really doesn't matter. You could have picked any of the equations because your answer has to work in all of the equations that you have. Okay, so I'm going to substitute that x that I got to be 1. I'm going to put it in right there. So 5 times 1 plus 3y equals 14. So 5 plus 3y equals 14. Subtract 5, subtract 5. 3y equals 9. And divide by 3, divide by 3, y equals 3. You know, and you can stop the video and do all that work because I kind of ran through it real fast. See if you can do it on your own and then check it with the video. Okay, so we get an answer, 1, 3. And we think that's the answer. Now, here comes the check. To check it, I take the top equation, 3x minus 4y equals negative 9, and I put in a 1 for x, and I put in a 3 for y, and I see if that makes a true statement. Well, 3 minus 12, does that equal negative 9? Yes, so that part looks good. But it also has to work in the bottom equation, 5x plus 3y equals 14. So I plug in an x value of 1 and a y value of 3, and I'm going to see if that works. I get 5 plus 9 equals 14. Yep, that works. So it checks. Yep, sometimes I'll put a check. Okay, so kind of a long video, sorry about that, but these problems are a little long. They take up a bit of paper. Okay,